Cool. So let's keep going on with this adventure. So last time we talked about top-down versus bottom-up explorations of code, and I may not go over these same things multiple times in the other code tours that we do, but maybe it's worth reiterating. Top-down iteration of a code base, where you're exploring a code base, is where you find the main entry points of code. This could be through some primary interface that is used, or interfaces. So maybe it's a CLI. Maybe it's an API endpoint, GraphQL, REST, whatever. It can also be a tandem of those two, and then you can take your pick. Additionally, you can go bottom up, which is that you find the leafs, so all the dependents, and then you kind of go from there and you say, oh, well, I understand that this module is just for formatting strings or something, and then this module is just for handling memory management or whatever, and you build up from there. And then when you get to that front part again, the top part, you know, oh, okay, you look around and you say, these are all those constituents. Basically, it's a different perspective of search. You can go inside out, so you can have this middle part where you look at the core logic, and there's a lot of projects like the ones that I run. I tend to prefer to have a core logic crate that describes the basic glue of what would be tied to interfaces, and then interface crates like CLIs or API endpoints or whatever. Those are basically veneers on top of that. They just hook into it. And maybe do a little bit of custom logic to rig up things. And then additionally, you would have the last bit, which would be, what would it be? Going sort of, I guess, both ways in. So you do a little bit of top down, a little bit of bottom up, and then you get to the middle. And that approach isn't bad, because then you sort of get this better understanding of what's going on in the middle stuff. Now, there may not just be one core crate when you're doing the inside out one. This is because maybe it's broken up into several things. And we looked last time here, and all of the rest things are kind of broken up across all of these different crates. But the main entry points are this jailer and this firecracker binaries that get generated. Now, excuse me. I think one of the really interesting things that we did was we explored the Python tests, which rig up and run the binaries. And part of the reason why I did that is that, sometimes it's not clear how to run a project. You go to the project, there's no documentation about it, there's nothing really exploring anything. You can sort of piece together from the tests, maybe, if there are any that invoke a CLI or CLIs in the right manner. Additionally, the project itself does have this, where is it? It's like, oh, sorry. Getting started. All right. There's this markdown file that I found describing how to set this up for all sorts of different projects. So, getting started with Firecracker. Getting the Firecracker binary. Cool, we're building that. We can build and run Firecracker. So, in production, Firecracker is designed to be run securely inside an execution jail, carefully set up by the jailer binary. Okay, so this is an important sentence because we sort of got that idea from looking at the tests. And we wouldn't have gotten that idea unless we found this document, right? And maybe, we were lucky and we looked and we saw, oh, there's a document section here. And it's got all sorts of interesting stuff like dev machine setup, getting started, device API, design docs, information about initrd and jailer, like what's initrd, right? Doc initrd.md. Oh, sorry, it's docs. Right, creating and using an initrd for Firecracker. All right, well, what does jailer look like? Disclaimer, the jailer is designed to work only with statically linked binaries, right? Stuff like that is really interesting. And if you still were not able to run the binary locally because it has a lot of finicky setup or specific stubbed data that needs to be generated or whatever, knowing where the tests are that instrument that sort of thing and discovering those tests and kind of pulling them apart gives you another way to invoke those, such that if we really wanted to, we could go into these tests and we could hijack a test, copy it and change it, make our own. It's providing some source level documentation, albeit not the best, about what to do. The reason why I say not the best is because it really does depend. Like what the project is and how much effort they've put into the source code itself and how readable it is. And that was one of the things we talked about when it came to reading code, right? Is that if you can't make heads or tails of a code base, one thing that you could do is just start rewriting the code yourself. All right. Cool. So let's do this. I think we've had 2 videos now, well, roughly 1 or 2, that describe getting sort of into building things and looking at tests, but we haven't really touched any Rust yet, and I'm really excited to do that. So let's go look at this running document, and we'll eventually have to come back to this because maybe we'll want to do this ourselves. It'll also give us some information about what's actually happening. And we also know that on this machine, when we ran the image, we had 18 failed tests, which was surprising, and they weren't marked as acceptable failures because we saw in CI that they passed, right? But yeah, so this is describing how to set it up, and here's configuring the micro VM without sending API requests, building from source. Building Firecracker, we did succeed with this, so we have a binary in our project that describes it. We don't have a release binary though, but we can build a release one if we want. It gives us an alternative to build Firecracker with glibc, which will not be a statically linked one, meaning what we read above, we can't run Firecracker in the jailer sort of environment. This is interesting because it's talking about failures. Some performance tests may fail when run on a regular desktop machine. That makes sense. Specifically, don't be alarmed if you see tests, integration tests, performance test process startup time.py failing when not run on an ec2.metal instance. You can skip performance tests with this. And I wonder that if we ran this locally, right, and if we saw which of the 18 failed, integration tests for performance failed, some security functional and build tests failed. So it was saying we could ignore integration test performance, but it's still a little kind of bothersome to see that these are failing, right? Nonetheless, some Linux distros use the KVM group to manage dev KVM. So this is about, we notice that this is an appendix and this is describing, okay, if we're trying to run this on our machine and we're running into some things with KVM, we can go look here. And there's also just a general guideline about how to set up Docker. Cool. So you have to understand that some of these docs for an open source project are probably coming out of, they're probably coming out of, maybe the project was originally closed source and they devved on it and they hacked on it and they got it into a place that was approachable. And then they probably went through, this is just an assumption of mine, but they probably went through a release process that described like, okay, is the history that describes any internal knowledge scrubbed, right, or squashed? You know, is there an open source license attached to this? Have we checked that it's presentable to the outside world? All that stuff kind of has to go through a vetting process internally, and then eventually there's a release of it. So we're likely not to see everything, but it's also not worth the effort to scrub all like internal tutorial documentation, right? So if somebody's coming to this project internally working at Amazon and they're confused about, I've been hired, I'm working on the Firecracker project, I've got this getting started guide, it's my first week, right? I don't have, Docker installed on my work machine. Obviously, maybe you go here and you say, oh, okay, well, I'm running a Fedora machine, right? So sudo yum install docker and then blah, blah, blah. This is interesting because it's not the way that I would necessarily go about installing it, but they do mention here of installing the official ones. But the reason why I bring that up is it might describe some of the background behind, why is the Firecracker project including an appendix on setting up Docker? Because it might have come from an internal point of view. So I'm just going to make a choice, right? And my choice is going to be based upon what do I want to look at? My habit with really complicated things is to go with my gut in terms of what interests me, so what excites me, but also in terms of like how I'm going to make sense of something. And so what I'm going to do is I'm going to start looking at the code that rigs up the Firecracker tool. And I'm going to start trying to get a sense of, how does this all play together? If you've never handled Rust before, if you've never looked at it as a language, it's your first time, or you're still kind of getting everything into your head, don't worry, that's good. I think that one really important thing here that we're going to do is I'm going to try to see. So it looks like all the dev tool stuff with test is PyTest related stuff, okay? But what I want to do is internally run a specific loop, actually. But if I can't, then I'll have to hack it. So let's go build, because that was build test related. So build the command we want to find, and I'm going to hack this script to basically let me run whatever here we go. Whatever Rust test I want. So you see that eventually in here, it's doing all this setup for building. So here's the jailer being built. And here's the primary Firecracker one. Cool, because that's the default workspace, right? We saw that in the cargo toml. So what we're going to do instead is we're going to just see, can I cheat here? And can I just run cargo build this guy? And I don't actually want to build anything. And I don't actually want to, I just want to make sure that there's no like weird directories or whatever that it needs to set up in order to do anything that's related. Cool, okay, so instead of this, I'm just going to say cargo test. So, tools, dev tool, build. Okay, interesting. So there is some setup stuff that's related to this. All right, so if we go back here, and we try this again, is this gonna pass? Yep, it is. So let's get down to here. See, so run dev control. It says run the cargo build process inside the container. We don't need any special privileges for the build phase, so we run the container as a current user group. And remember that this is the dev tool, right? So we don't want to run this locally. So that's part of what we're doing. So we can take this guy, go back up to our thing, here. Command build. We're gonna spoof this command, right? That one's now gonna get invoked instead of the other one. And this should run our build. Yep, it is. Set, change this out, test. And then once that finishes its test build, it should run what we expect it to run, right? Cool. So one of the things that this had was the target directory was the container cargo target directory. We can try to fake that here and see, okay, can I run the same thing? Yep, cool. So we see that there's actually only 2 tests that run across all of this. And the 2 tests are metrics test, test interest list, and metrics test, test periodic metrics. So that's interesting. So if we go metrics rs test, yep, you'll see that it's got test configuration stuff plugged in under a flag. And then these are the tests, interest list and periodic metrics. And yeah, this is interesting. I'm not sure what sort of metrics this is intended for, whether it's internally for Firecracker or for AWS kind of metric polling access or whatever, or if you were to run Firecracker on your own hardware, if it was its own stuff. Doesn't really matter. So we see that there's not really any other tests here. Are there any tests for this CLI? No, because all the Python tests are the ones driving it, okay? So this isn't super helpful to us, this command, but how about we just start looking at these, right? So let's start with this top-down approach, and then we'll look at a couple of leaves, right? And then after we've looked at a couple of leaves, we'll go back and sort of maybe look at some chunky middle code. I'm going outside in, because I don't think it will make a lot of sense to try to find, because it's not really clear, right? You should start at clear boundaries. And if the internal kind of middle bit is clear, then you can start there if you want. But if it's not clear, it's better to try to start at like a clear entry point, a clear leaf in the graph or tree. So what is this thing doing? We're going to start top down. Here's main. The logger is initialized. There's some logger thingy here with configure and expect. There's a thing that registers signal handlers. Okay. And it actually exits with a very specific exit code. Gets a hold of a single instance of stood in. Okay, doesn't lock it. Panic set hook. Says start Firecracker by setting up a panic hook, which will be called before terminating as we're building with panic abort. It's worth noting that the abort is caused by sending a sig abort signal to the process. So this set hook, what's it gonna do? We're currently using the closure parameter, which is a panic info reference, for printing the origin of the panic, including the payload past the panic and the source code location from which the panic originated. So what is the point of this, right? Okay, so we see this metrics thing here. And when a panic happens, we have this hook that runs, and it says error, Firecracker blah, which is the info, panic info. And this described what that was to us. Then we lock stood in, we set canonical mode on it, which we can talk about another day if we talk about terminals. And it says failure while trying to reset stood in to canonical mode. If that fails, then, okay, we've got this thing set to canonical mode. Then we increase the panic count, all right? And then we write metrics out. So we record the metrics, we write them out, and then we dump out. So there might be several panics that happen, triggering these hooks to come into play. They'll record the number of panics, and then they'll write them out. So that partly, surprisingly, describes the metrics thing, which is a static instance here of a logger. Right, so the logger, init cargo tunnel metrics. So yeah, we're just using a lazy static to set up a static reference to the metrics, Firecracker metrics thing. It uses that other metrics module to set the self up, and then the metrics one has metrics buffer if it's initialized, which is an atomic bool, and then the app metrics, which is some generic thing. So it's generic over something, which is Firecracker metrics. And then we can go find write, and write produces a result of bool, and this thing is going to metrics error serd, extract a guard, and turn the thing into, so it's going to turn the thing into JSON, the app metrics. If that's okay, then it's going to try to pull out a guard on the metrics buffer, and then it's going to write everything to that metrics buffer, right? And that metrics buffer might have stuff in front of it that also pushes it out to maybe an external place, right? Won't go too deep into that yet. Excuse me. So, argument parsing. This gives us a sense of all the arguments that are provided. So API sock, ID, set conf level. These were all the ones that we saw when we ran. This, right? So let's unhack our scripts. Right. Now that that's stashed away, we don't really need to keep that code, but we might as well. Oh, build. That's where it's at. Cargo target. x86-64 Linux. Musil. Debug. Firecracker. Permission denied. That's interesting. Because if you try to run it without any args, it does some initial stuff. So this lines up with this, right? And we had to look through that. Then what it does is it parses those from the command line. And this is a really good pattern. So what some people will do is they'll just use panics or accepts or whatever. But if you're running stuff on Linux, you probably want to be really explicit about your error codes. And in this case, we're going to just say something like, oh, okay, I couldn't find this one thing. I'm going to exit with fc exit code arg parsing, right? And so benches main builder lib. So let's go find this fc exit code arg parsing. So this is a bit old school. They've got this big table of exit codes that they're describing. They have clear documentation that describes what does this exit code mean. They're actually using cargo doc stuff. So we could run cargo doc on this to get some documentation out. And we probably should, right? So if we go git-pop, go back to our dev tool thing, and here we're going to say cargo doc. Right. So dev tool build. So tools, dev tool, build. Okay. And that's going to produce our documentation, and we can look over that documentation. Now, we could probably go find that published somewhere online. A really handy thing to do is to actually set up keyword searches inside of your browser. Chrome supports this, Firefox supports this, Safari might. The gist is that you can bookmark or explicitly set some keyword like docsrs, or I have it for rstd, for example, to go to the Rust standard library, iterator. And what this does is it will, I actually don't have it on this. That's a really good example of something. So if we go to like rustd lib, I can show you how this is set up, right? So the way to do this custom search functionality, right, is let's see here. I'm using Firefox for this, but you can do it on Chrome like I mentioned. Basically, you create a bookmark that has this %s thing, right? %s Firefox search keyword. Let's see if we can find it. There we go, how to search these things from the address bar. So you right-click on the context menu, this guy, add a keyword search for this, which is going to make this tricky because I can't seem to get this down. Keyword search, huh? Keyword. So we can't add more here directly through that. I kind of wish you could. You can in Chrome, which is a bit of an advantage. But the keyword search thing is effectively this idea that we're going to go here. We're going to bookmark this thing and then mention the keyword. So it's possible that my version of Firefox is quite old. So this is ESR. I try to run a newer version of Firefox if I can help it, but let's set up a keyword search for this. Rustd lib, and we'll open up the context menu, and then you say, what is it? Select add a keyword for this search. All right, so you go here. Ah, that's what it is. Okay, that's what it is. So you go here and you click on this thing. What is going on? What is happening? Here you go. Yes, perfect. We found it. So you give it a name. That's the keyword that you're going to do for this, right? Sorry, let me give it a proper name. Rstd, and then we're going to say rustd standard library. Learn how to spell. Now when we do things like rstd iterator, we're going to wind up with a direct search into this, which is super cool. And next time we have a talk, we're going to specifically go over some cool tricks with docsrs. Additionally, we can go to docsrs, and we can add a keyword search for this. And I'm going to say docsrs. Save. We can change that if we want. They just wind up as bookmarks, but I don't believe that you can add them as a bookmark, which is a bit funny. I've been like fishing around, and I actually have a document here, a little blog post I did this on this very point, but I think I'm going to probably extend upon this and sort of clarify it in addition to these videos. And then next time what we're going to do is we're going to get really, really crystal clear about going into the VMM crate and the API crate, and we're going to explore the rest of the main module for Firecracker to explain why we're going to go into those. And then after that, use a lot of docsrs and explore that. And we're also going to, custom search functionality. And then we're also going to, what's the last thing that we were going to do? We're going to try to run the locally generated docs that we did in our browser, right? Because that's a really handy way, because they're not actually present on docsrs, right? This is some stub docsrs thing that doesn't have any content. Cool. So I'll catch you next time.